All right, so on this problem, I'm noticing that I'm going to need to, at some point, in order to get x by itself, I'm going to have to deal with this adding 11 pi over 6 by subtracting 11 pi over 6. And then I also see that I'm going to have to divide both sides by 2 to get x by itself. And the reason that I know that is because eventually I'm going to find the angles that have this right cosine value. I need to find the angles that have this cosine value. And then after I do that, that's what 2x plus 11 pi over 6 is going to be. So I need to actually solve for x by finding more options than just what's happening in the first time around the circle, even though my solutions say that I'm looking for 0 to 2 pi. So I'm looking for all the places where the cosine is negative 1/2, and that's this spot around the unit circle, which is 2 pi over 3, and this spot around the unit circle, which is 4 pi over 3. You can use your unit circle to find those spots, but this is the thing. Because we know we're going to subtract 11 pi over 6, and then we're also going to divide both sides by 2, that's going to make my angles smaller than they used to be. So I'm not just going to use 2 pi over 3 and 4 pi over 3. That's some of them, but there's also more to it. So I'm going to set the whole name of the angle 2x plus 11 pi over 6 to be equal to a list of different angles that all have the same cosine value. So I'm going to include 2 pi over 3. I'm going to include 4 pi over 3. I'm going to include another time around the circle past 2 pi over 3. And to get that, I would do 2 pi over 3 plus 2 pi. But 2 pi is secretly just 6 pi over 3. So I can see that that's going to be 8 pi over 3 now. And I'm going to do the same thing for 4 pi over 3, but go around the circle another time. And so that becomes whatever 4 pi over 3 plus 6 pi over 3 is, which is 10 pi over 3. Just for good measure, because I see that we're doing something that's like 11 pi over 6 is almost 2 pi, and so I'm going to be subtracting something that's almost 2 pi, and then also dividing both sides by 2. I feel like I need to include more answers, and so what I'm going to do is I'm going to take each of these and just add 2 pi to them again, and I think I'm going to do it 2 more times, just to kind of show everything that might happen. So that would be 14 pi over 3, and then that would be 16 pi over 3. Another 2 pi over the top of those is 20 pi over 3, and 22 pi over 3. Okay, now I know that's a lot, but I think it's going to serve us really well, because now what I can do is I can just sort of solve for x as if all of these solutions over here were one of my solutions to deal with. So I'm going to erase that box now. I don't want it there anymore. Okay, let's see. I need a common denominator because I'm going to subtract 11 pi over 6 from both sides. And so each of these needs to become a common denominator with 11 pi over 6. So I'm going to make all of them have a common denominator of 6. I'm going to do that off camera, and then I'm just going to move on with my life. Okay, so whatever I get here is going to be what 2x is. And so I'm going to subtract 11 pi over 6 from all these angles to see what I get. So I'm going to get negative 7 pi over 6. I'm going to get negative 3 pi over 6. I'm going to get negative 5 pi over 6, or sorry, 5 pi over 6. I'm going to get 9 pi over 6. I'm going to get 17 pi over 6. I'm going to get, let's see, 21 pi over 6. 29 pi over 6. And then 33 pi over 6. Okay, so this is a whole long list of all those. Then I need to divide them all by 2. But here's the thing, these are negative, so I can get rid of those because I know that my answers have to be positive. I also know that they have to be between 0 and 2 pi. And so when I divide all these by 2, I need to make sure that my answers are between 0 and 2 pi. To divide a fraction by 2, we can just multiply the denominator by 2. And so we'll get 5 pi over 12. We'll get 9 pi over 12. we'll get 17 pi over 12. We'll get 21 pi over 12, 29 pi over 12, 33 pi over 12. So the things that are over 2 pi are anything greater than 24 pi over 12 because 24 over 12 is 2. And so these 4 solutions right here are my answers. I think it's helpful to have one more example, and I wanted to use one that has tangent because tangent is a little tricky. So I'm going to subtract 3 from both sides, but before I do that, I'm going to deal with the fact that this is a fraction that has a plus in the top numerator, and so I can split that up. It's a hard I can break apart. So I can say 9 over 3 is 3 minus root 3 over 3. And there's nothing I can do to simplify that, but that's okay. Then I say equals 3 plus tangent of negative x. All right, so now I'm kind of where I need to be. I'm going to subtract 3, and I get negative root 3 over 3 equals the tangent of x. Now I need to think a little bit about my unit circle because tangent is a little tricky for me. And I know that to get root 3 over 3, I need to do root 3 over 3 is going to be one of those ones where I would have rationalized it. And so I would have had something that's like 1/2 over root 3 over 2. At some point, I'm ignoring all the negatives because I'm going to have to deal with the negatives in a second, but I'm just trying to process. So that means that this is sine and this is cosine. And so I need to find where the x values are root 3 over 2 and the y values are 1/2. And so these are those sort of flatter angles. They're the pi over 6 angles. So let's see. But the thing is, I need them to be negative because there's this negative chilling here. And so that means in order to make that negative, I need to be in quadrant 2 or quadrant 4. And so that means that my answers are either, so I'm going to say negative x because that's what this part says. Negative x equals, and the angles that have tangent of negative root 3 over 3 are 5 pi over 6 and 11 pi over 6. But the thing about that is I know I'm actually dividing both sides by -1 because of this negative right here. And so I actually need to look at the negative angles that point to the same places around the unit circle, that point to these places on the unit circle, so that I can multiply by -1 or divide by -1 and get back into the positives. So this angle in the negative direction is negative pi over 6. And this angle in the negative direction is negative 7 pi over 6. Okay. Now, if I were to go another direction, another time around the circle, I would already be greater than 2 pi. I'm not dividing or subtracting or adding or anything by anything except for 1. It's -1. But that means that I don't need to worry about another time around the circle because this would already be too far. This would already be too far. And so that means that I can just sort of just look at these 4. So I'm going to take both sides and I'm going to divide by -1. And I'm going to get x equals negative 5 pi over 6, negative 11 pi over 6, pi over 6, and 7 pi over 6. And so I can see that these are negative, and so I can cross those off, and my answers are just going to be x equals pi over 6 and x equals 7 pi over 6. So those are they. That's it.